Hey everyone, it's Naz here and welcome to my first ever video on this channel. I will be developing my first commercial game and taking you along this ride. Many times you see experienced game devs creating their own games and making it look so easy. So I decided to document the whole process and show you how you can make your own game and overcome any difficulties you might find along the way. Also, I'll be streaming all of this, so if you'd like to join me, I'd appreciate that very much. Okay, so now heading into the game, Unity. In this episode, we'll try to make a capsule walking and jump. First thing I did, I already set up a small scene, nothing, no big deal. I just came here to game object, to the object, sprites, and I added a square and a capsule. I give them some colors, no big deal. Things you gotta worry about now. First, let's give this ground a box collider and you'll see why in a second. Just give me some time to explain it to you. And now to the player, we gotta do the same thing. And let's give it also a rigid body 2D. Here, the rigid body has this connection. Let's create a script. This script will be for our player controller, right? We need a script that will control everything our player does. I like to keep things nice and tidy, so I'll create a folder and name it script and get this in there. Opening this up. Let's head into Visual Studio so we can just start coding. Right, so when we open up Visual Studio, we start with these two functions. I'll just clear up the void start function because we won't need it right now. Let's start by making our public rigid body 2D RB and creating a function for player movement. So this, okay, and we'll call it on the update function, which is a function that is called on every frame on Unity. Inside this function, we gotta do some things to create the movement. First, we'll detect the input from the player by creating a vector. And so, what this does is it creates a vector that detects our horizontal input. So when we press the A or D keys or the arrow keys to the left and right, Unity will already detect them and make them go from the one side or the other. We chose getAxis raw instead of getAxis because getAxis interpolates from 0 to 1, going through all the values in between, making it slowly ramp up in velocity, while using getAxis raw make it go straight from 0 to 1 and making the movement more crispy and not so slippery. Now, I gotta go into vector 3 and make sure that our input vector has a value of 1, a length of 1, because otherwise what will happen is we won't have an even movement across all directions. Direction and input dot normalize. Now gotta create a public or not a float called speed, which will have a value of 10, and we'll put the F there just so that Unity recognize that as a float number. It's not actually necessary, but it might help in future setting. We have the direction and we have a speed. So what that does is it creates a velocity for us. Create the velocity, and which is equal direction times speed. Since we have the velocity now, it's just left for us to create our move amount. So how much is the plane going to move each second, let's say. The update function, like I said, is called once per frame, and if the player movement was called once per frame and the move amount was applied again once per frame, it would make that the machines who run at higher FPS would make the player move more each frame and so be faster, while machines that would run on lower FPS would make it run slower, which would not be fair to the player and would not make an even gameplay. And so we make it be by time and not by frame so that it's equal among all machines. Now that we have our move amount, it's just left for us to add it to our player. So we get transform, which is the kind of a database that stores the position, scale, and rotation of our object, and we go apply a translation to it, which will be exactly our move amount because it's already a vector. Now, the next thing we gotta do is the jump. For the jump, we need two variables. One is our float called jump force, which will be equal to 10f, and our boolean called can jump, and you'll understand why in a bit. And so let's create a void player jump, and it will be called if and only if input dot get key down key codes dot space, and if and only if can jump equals true. That happens, then we call player. And so how will we handle jump? We remember we added the rigid body to it, so right now we gotta take that rigid body and add a force, an instant force, which is an impulse. So add rigid body dot add force, a force which is vector 2 dot up times our jump force and the force mode to D, which will be an impulse, like I said. And then our can jump, because if the player already jumped, our can jump equals false. So what this does is it takes the vector up, so the upper vector, and it multiplies it by our jump force, which is 10 in our case, but you can choose it to whatever you want. And then we say that it's an impulse force, and you see in a bit what it can make. In return, they can jump false, because if after the player jumps and is in the air, and we don't have this boolean determining whether it can or cannot jump, it will jump nonetheless if it's on the ground or in the air, and that would not be good because you can jump in the air, can you? So right now we make it false if the player jumps, but we gotta make it true again if it's grounded. So we're going to our private void on collision enter 2D, which already creates this collision, and we're gonna get collision dot game object dot name equals ground, then can jump equals true again. And so if my calculations are right, we should have a jumping system ready to go. Putting back into Unity, let's check if all our script is correct and if it's working quite well. Okay, we have movement, we have jump. It's a bit floppy, but we'll fix that in a second. And he cannot jump on the air. Right, everything we wanted. So now let's go to our rigid body and tweak the gravity scale. So this will make the player go down faster, which will make it look less floaty. And I have a value in mind, which I tested before, which is 3.5. You can tweak this however you want, and we'll make the collision detection continuous. So this makes that if the movement is fast for the object, that it's better to detect, because if it's on discrete, it might happen that the object gets through the other, and that would just be a bug in game. Let's just test it now. Movement's the same, and jump. It jumps less because it has more gravity, but we can make the jump force higher so that it just has a better jump. But you see, it has a nice height. We can tweak that later. It seems heavy, it seems like a heavy object, and it's great, everything we wanted. And that will be it for today, guys. Hope you enjoyed, hope you're here for the ride, and hope you see it in the next videos. See ya.